Okay, good afternoon, ladies and gentlemen. So, our objective for today states that students will be able to compare expressions and equations to determine if they are equivalent. So, remember yesterday we were doing that example where we were looking at the pools that were surrounded by a border of tiles. So, the idea for today is we're going to try to figure out a couple of different ways of expressing the amount of tiles that go around the border and then seeing if they're all actually equivalent or not. So for example, we have this pool right here. It's covered with the tiles. Remember, the length of the pool is length S. S is just a variable that represents the side length. So the way that this picture shows thinking about it is kind of breaking it up into these sections. So it looks like we have 4 of these yellow sections, and then we have these 4 corner tiles. So if we're trying to think about counting up the amount of tiles that we would need here, that's what we would think. We'd say, okay, so I know that this here is going to be 4 separate tiles, but then we have to try to figure out how many tiles is each of these blocks represented by, right? And the way that we do that is actually pretty simple, because we actually know that, remember, over here, based on the definition, this pool has a length of S feet. So if this is S feet long, that means that I would have S tiles here. I'd have S tiles here, S tiles here, and S tiles here. And then I have another 4 tiles here, right? So for example, if this was 3 feet by 3 feet, S would be 3. So I would have 3 tiles, 3, 3, 3, right? Now, I would go ahead and just add all those up together. So that would be like saying S plus S plus S plus S plus 4. That tells me how many total tiles I have. All right, so again, that's one way that you can think about counting up the total tiles. We're going to look at a couple of other examples of that today. So if you scroll down the page, the next thing that you're going to see here is a couple of different expressions that we're saying some students came up with. So equations, not expressions. Remember, an equation has an equal sign. So the first equation is n equals 4 times s plus 1, s plus s plus s plus s plus 4, 4 times s plus 2, 2s plus 2 times s plus 2. So they all look slightly different, but we are going to try to figure out if they all actually are the same thing, right? And what you might be noticing right now is that one of those we actually just saw above, right? See if you can identify it. Remember, this one here, s plus s plus s plus s plus 4, is actually that one there, right? We just wrote that up on the top page. So we're going to try to figure out, looking at these other two, how are they thinking about breaking this up to get those different times of expressions, right? So what you're going to do on the next page is try and use what you see here to kind of color code the diagram on the right hand side to show how they might have come up with the expressions on the right hand side. So over here, s plus s plus s plus 4, we already know that's the one that we saw on that first page, right? So that's kind of like saying, okay, this side length over here, that has a length of s. Same thing with this one here. This one here. Oops, wrong yellow. And this one here. And then the 4 comes from the 4 corner tiles, right? Which again, I could just color those a different color. I could say, make those green. So that's a way of thinking s plus 4 plus s plus 4 plus s plus 4, right? Now, you could say, okay, so what about, say, this one here, 4 times s plus 1. Can you figure out a way to highlight this here so that it shows what 4 times s plus 1 would look like? All right, and I want you to try to think about it, see if you can highlight it. If you can't figure this out, don't stress about it too much, but I'm going to go over it during the live Zoom session, not in this video. So come to the live Zoom session if you need help with this part. Same thing. How would you do 4 times s plus 2? How could you do 2s plus 2 times s plus 2? So think about it like you have 2 s's and you have 2 s plus 2's. All right, so you can pause the video here, try this section out. I really don't want you to spend too much time here. If you're not sure, you can't figure it out, don't spend more than 5 minutes on this part. Just go on to the next part then. But again, come to the Zoom session. So next part, right? We have 4 different equations. We want to figure out, are they all actually the same, right? So one way that we can do that is we can just kind of pick a value, right? So let's say we're talking about a pool that is 10 feet by 10 feet. And we want to see how many tiles would it take. If these equations are all the same, I should always get the same answer. So what we can actually do here is just go ahead and try substituting in the value of 10. So just to show you how to get started on this here, right? S equals 10. If I want to see what this equation gives me, I basically need to replace the s in the equation with the number 10. So I would say, okay, that's 4 multiplied by 10 plus 1. And then you would just use your order of operations to solve this. Remember, order of operations, you're going to say parentheses, exponents. You do multiplication or division first, and then you do addition or subtraction after that. Okay, so you're going to do the same thing for the next 4 here. Sorry, all 4 altogether to see if you get the same result for each of them. Right? After that, based on what you see here, do you think that these equations are all the same? Explain why or why not. Then, for the last page, we're going to try to see a couple of examples of when equations are equal, when they're not equal. So it says here, is one value enough to check in order to prove that 2 expressions are equivalent? All right, so we're looking at 2 equations over here. I have the equation 2s plus 1, the equation s plus 2. So looking at them, do you think they look like the same equation? Right? Now, you might say yes, you might say no. We'll talk about it during the Zoom. To see if they're equal, let's try substituting in this value of 1, just like we did above. So again, all you would need to do here is take the value of 1 and substitute it in for s. So you rewrite this here, saying 2 times 1 plus 1, and then for this one, saying 1 plus 2, right? Do you get the same value for both of them, right? And does that mean now that the 2 equations have to be equal? So do that part first. And then the next part is checking a different value of s. So now we're checking for an s value of 3 and substituting that in. Do you find that they are both equal again, or are they different, right? And based on the results that you see there, you're going to answer the question, which just says to you, based on the results above, do you think that the 2 equations are equivalent, right? Are they the same thing? Why or why not? Then you're going to do something similar on the next page. You're going to look at 2 different equations and you're going to check for 2 different values. So you're going to see, okay, so let's see when s equals 5, are they the same? When s equals 10, do they give you the same thing? And if they're both the same, do you think that there is a value that makes it so that the 2 equations aren't equal? All right. Please make sure you come to the Zoom session so I can assist you with this, right? These pre-algebra skills that we're learning right now are going to end up being very important when we get into algebra next year. All right. Good luck.